Hey y'all, we are going to do a composite of functions example. Okay, so a composite of function is whenever you take a function and you plug it into another function. The notation itself is an F, a composite symbol, and G inside of parentheses, and then you have your X inside of parentheses. The way that's read and what it actually means is F of G of X. If you notice when I said of, I opened a set of parentheses, so F of G of X. What we do is we replace the X's in our F with G of X and we solve. So let's say that our F of X function was, where is it? 2x squared plus x, and our g of x function was x plus 3. So those are our functions. What we're going to do here, for this first example, is we're going to find, if I can change colors, f of g of x. So we know that this means f of g of x, close, close. So what this is saying is f of, it told me to plug in g, right? Well, my g is that x plus 3. So if I look at my f of x function and I plug in x plus 3, wherever I see an x, then I can get to my answer. That would be me doing, apologize, that would be me looking at my f of x. I get 2, and then there's an x. So what I do is plug in x plus 3. In my original f of x, it's being squared, so here it's also being squared. And then plus, I have an x, but what that's telling me, because I'm plugging my g of x into my f of x, is I'm actually going to change it to x plus 3. X plus 3. Okay, so what I need to notice first is that my x plus 3 is being FOILed. That is x plus 3 times x plus 3, because it was being squared. And if you do FOIL, you get x times x is x squared. X plus 3 is 3x. 3 plus x is 3x. 3 times 3 is 9. Signs are the same, so it's positive. So this is what I plug in now to my parentheses, because I've evaluated it being squared. So it's no longer going to be squared, but it is going to get replaced with that. So 2 in parentheses is now this. So I get x squared plus, if you look here, my positive 3x and positive 3x, that becomes a positive 6x. And then positive 9 plus x plus 3. And then here what I do is distribute my 2 through, and I get 2 times x squared is 2x squared. 2 times 6 is 12. Signs are the same, so it's positive. Don't forget your variable. And then 2 times 9 is 18. Signs are the same, so it's positive. And then we have a positive x and a positive 3. So what I do here is combine like terms. I don't have anything else with an x squared variable, so it is just going to be brought down. I do have a positive 12x and a positive x. Combine coefficients, keep and keep. And then I have 18 and 3, which is 21. So looking at f of g of x, that is what I get. If you were asked to do g of f of x, that would actually be g of f of x. And what you would do is you plug your f of x into your g function. Okay, so let's say it actually asked me to find my f of g of 2. Well, I know that my g of x was x plus 3. So this would actually be f of, Instead of x now, it's 2 plus 3. So that would actually be 5. And if we plug this into my f of x, it was 2x squared plus x. So I would get 2 times 5 squared plus 5, which is 2 times 25 plus 5, which would be 50 plus 5, which is 55. So it's an example of plugging the actual function into another function, and then this is actually plugging my g of x into f of x, but instead of just g of x, I'm specifically evaluating my g of x function at 2 and then plugging it into my f of x function. Okay, thank you. Bye.